Hello and welcome everyone to day 2 of Impact 2024. I feel very much, I've met maybe 50% of you, so I feel very much like this is a room of friends to me. A room of friends that want to do something, want to get something done and something changed. For the rest of you that I don't know, my name is Stein Danielsen and I'm a co-founder and CSO of Cognite. We have a packed day today, so let's just get started. The first session is about the impact of real-time digital twins and AI robotics. So we saw some robots on here, but this is what we talk about. And there are 4 big trends that is happening just right now that you need to pay attention to. The first trend is that now we have large language models, and specifically vision language models, the combination of vision and language, that understands any type of data that we have. So we read all the documents, we look at all the 3D models, we look at all the pictures, and we understand what's in them, also in the diagrams. These models are fantastic with the power of what they can understand. So we don't have to make special models anymore for all these different types of data. We use these large models to understand all of these different types of data. And then we extract the data and put it into a knowledge graph. So the knowledge graph is super important in combination with the large language model or the vision language model, because we call it grounding of the model. We just tell it our state, like what is the case at my plant, what is my industry, what am I doing? And then if I ask a model like this, what is the difference between these 2 different pictures? If I hadn't grounded it, it would say the camera angle is different. The sun is a little lower in the second picture. But in industry, we don't care about the camera angle or the sun or the shades. We care about the valves, the spills, and those type of things. So when we combine a large language model with a knowledge graph in Cognite Data Fusion, and I ask this question, what has happened here? It tells me that the valve was closed and is closed, but there is a spill on the ground. So it knows what I care about when we ground the model like this. We can automate all of this capture even for physical data with robots. So as you can see on this next slide, the robots can do this data capture autonomously. So you can build your digital twins with a data capture autonomously. All the data that's been captured is being understood by these large language models and vision models, and it's put into the knowledge graph automatically. Here you can see the robot doing autonomous missions, going over and over and over many times per day, scanning this area, and building the digital twin. So the digital twin is just really like a 3D view of the knowledge graph. And in the knowledge graph, we have everything. Every document, every diagram, every real-time sensor value is present in the knowledge graph and in the digital twin. So with this approach, you use the robot to get an evergreen, it's always updated, real-time sensor values, everything in the digital twin. The impact of this is that all your workers, all your partners, all your AI questions, and all of your AI agents have super easy access to the current state, the full state of your site, with really no manual intervention on your side. All the processes we have, all the processal pieces now, all the processes are automatic. The second trend is that we get robots that look like people. So you saw a robot that looked like a dog. You also saw a couple of dogs up in here. I don't know why we started making dogs, but now we have robots that look like people. And on this chart, all of these robots on this chart, they were introduced this year. Not 2023. All of them, except the green one, was introduced this year. And there's many more as well. So why do we see this boom of human-like robots? There is a classic explanation that everything is built for humans. So all your brownfield sites, maybe you have trouble employing more people to them. Maybe you want to automate them by robots. But they are brownfield and they're made for humans. So you need robots that look like humans. So that's the classic reason. But much more importantly, and the second reason why we see humanoid robots now, is that we have ChatGPT. And you might wonder, why? Why does that need a human? So you can, of course, use ChatGPT to take a command, like, say, go to the separator tank to send the robot in that sense. But we now have found a way to run the robot motors by ChatGPT. To run the motors, not just understand what you want to say. And we can use a human to just show what we want to do. Like you maybe saw here on stage, where Christian was showing how to close a valve and wave and those type of skills. We just have to show it, and then we get that data into ChatGPT or a similar type model. And then the robot can do this autonomously. But if we need to show it by a human, and we want to mimic what you're doing, the robot also needs to look like a human. And that's why we see this boom in humanoid robotics. Also, the cost is coming down dramatically. So you saw the robots on stage, they're $150,000 or $200,000. But these robots, most of them will have a price between $20,000 and $30,000. So as we can train them, as we can train the human, and they will learn all of them at the same instant, we will have maybe something close to free labor by going this way. So let's look at an example how to train this. So this robot is out making or updating the digital twin. We come up to this valve. We see that this valve is open, and that's not correct. It's supposed to be closed in production setting. So this alerts the operator. The operator can be anywhere in the world. He just puts on the VR headset like you saw Ole Christian had before. It can be any VR headset that has hand tracking, so we need to see the hands and track the hands. Operator goes up, the robot is already in position. So it knows that we want to do this, so it's already in position. And the only thing the operator needs to do is to close the valve. So she sees in real time this view. So as she moves her arm, she sees the robot arm like this and can close the valve. The good thing about this is that we don't need the robot to understand how to close the valve because humans know how to do it. So here the human is teaching the robot. But much more importantly, this data is the input data. We capture all the images that happened here. We capture all the torques and all the forces on the arms, and that goes into the training. And research shows that we need to do this 50 times, and then the robot can do it by itself. So then it has the skill of close this valve. So with all this data, this is how it works. You can see the tracking of the hand and how the robot mimics those commands. You can also see here the hand tracking, these white balls on the hands, and how it looks like to the operator as it moves the hands around. So when we get all this data, we start to put them into this ChatGPT-like large model. We call that not a large language model, we call that a robotics transformer. It has vision, like ChatGPT, it has text, but it also has all these forces. And what we get with this type of model when you train that, we get hand-eye coordination, like you and I. You know, I don't know any of the coordinates of my hand. Still, I can do lots of different things. I have no idea what the coordinates are. And this is what we get here as well. We have hand-eye coordination. This robot can pick up this cup, no matter where the cup is on the table. And we can train it by a human. And it does not know any coordinates ever. So this is the way to train the skill. You can train any kind of skill like this. So this is the third trend. We can now train robots. And the impact of this is that we don't have to go to the sites so much anymore, and we can automate the closing of valves and things like that if we want to, checking that cabinets are closed, things like that. The final trend is that we have AI agents now. The way I like to think about agents is like a virtual person. A person that I can't just ask a question, but they will actually do work for me, like an employee. And in Atlas AI, the agents have access to all the skills of the robots through tools. So you're actually giving a body to the virtual human in this way. So with Atlas AI agents, you can close valves, you can open doors, you can make sure cabinets are closed, you can press elevator buttons, you can do all these things. And I can create an Atlas AI agent that I call maybe the operator. And it will do operator rounds for me. So I have an agent that does that. We also can have agents use agents. So maybe I have 4 operators. They do operator rounds, they do different things. And then I have a operations manager agent that is the boss of these 4 other agents. And then maybe I have a site owner, which is the boss of those again, that uses these agents. So you can mimic your whole organizational hierarchy in this way to set up very complex processes for operations, maintenance, root cause analysis, all of the things that you do on a daily basis. So this is fantastic news, both for industry, because we have so many building blocks now to automate and to really get lots of change going. But also for your home. So I'm thinking that we will all have butlers or like robot servants in our home, maybe like even a head butler and a group of servants as well that can go fix your cabin in the weekend. Of course, make all the food and make sure everything is clean. So this is fantastic. The thing though is that we already had a lot of technology. We had robots like you see before. When I go around visiting different industrial sites, I don't really see lots of robots around. So there is some blockers here. Why is it that we can't get started? But one person that I will bring on stage, Anette Jacobsen from Equinor, when I visited them, they have something like 6 different robots in production and actually making monetary value ongoing. So I thought to bring her here to show us how to get started with AI robotics. So please join me in welcoming Anette Jacobsen to the stage.
So, thank you, Stein. A short intro of myself. I started my career as a skilled welder. I became Norway's first female welding instructor. And then I also became a specialist for offshore valves and took a bachelor degree in computer science. And then I've been working as an engineer manager for a couple of years, and now the last 15 years as a project leader for offshore and onshore constructions. And now the last 6 years for pilot robotics project on onshore facilities. So, just a minute. Stein.
Yep.
Do you know what's the first statement I always got when we started initiating a robotics project?
No.
Robots, one must realize that these have limitations. That is the last question we're going to ask. Do not ever start an idea with a conclusion. You need a system, you need an architecture to follow here. You need to map out the problem, you need to do serious research, and you need to find the conclusion. That's crucial.
What type of leader do you need to be to run a plan like this?
You need to be a crystal clear leader, and you need to have a crystal clear leadership. Next slide, please. So, a couple of years ago, I had a vacation in Florida. I went to NASA's launch area in Cape Canaveral. I took this trip around with a bus, and I saw all those launch constructions, rusty old ones. And I got a flashback to the refinery I've been working for the last years. I couldn't see the difference between that tower and the launch tower, but the launch area in NASA has gone all the way to the moon. We have never gone to the moon. So I always say when I have a speech, 54 years later is no excuse to do any robotics development. Next slide. So I will now show you how you actually use a strategy to actually achieve your goals for robotic solutions. You always start with a good or bad field experience. You get a brilliant idea that you want to use robotics, but you have to take the ownership, and you have to map it out. And then you have to, of course, mature use case, as all project leaders always do. But you need to build that on with the competence to mature that use case. And I always use a very simple lean method as a note. In Europe, they say it's an A3 method. It's actually a paper sheet like this, and you square it to the quarters, and you have your background and business case, and then you analyze the present situation, and then you analyze how the desired outcome you want to have. And the most important of all, then you got all the actions and measures from this team who has been working on this A3, and here you have your preliminary start of your project. Now you have the underlay and the documentation to go as fast as possible out in the market. You have a use case, you have a problem, and you need to find the robotic solutions. So at this stage, you have tenders is coming in, and you have the solutions. So now you are going to build up the whole project. And here I will show you how you can have a success criteria to reach the best AI or the best machine algorithm you will have. But first of all, you need to identify the pain points you have in the field. And I have a list, and everyone in here, they know exactly what challenges are in the field. But as I said to you, now we have the solutions, but now you also have involved the contractor. You have your internal company team, and you have the contractor team as well. So now you are fused together to work on our robotic solutions, where you can achieve all this in the end and have the perfect business case. And there's one important thing is that you need to accomplish this HAC. You need to have cost effectiveness, and then you also need to show that you can improve the OPEX in your company. And when you have built all this project, now you have prepared a data capturing. You also, with the team, have found what data flow lines you need, and now you can start the machine learning and to prepare the best algorithm in the world, to put it that way. And now, Stein, we're hitting the minefield.
Yeah, the minefield.
This is a minefield. There is a problem in the oil and gas field today, and that's EX area. In Europe, in 2004, the Arctics were more strict for electrical equipment in the field. And worst of all, it's not adapted to the new technology we have today, like robotics. So they haven't matured it either. So EX certification for robotics is not suited for robots. And there are people who have tried to EX certify robots, but that hasn't managed the whole total ignition risk you have on a robot. That skipped some non-mechanical parts actually on the device. So therefore, it's quite important very early, as we had done in our project with Spot today, that we working quite close with DNV, the Norske Veritas. This is an independent, non-commercial partner who have no interest in your project if you have a success project at all, no commercial interest at all. So they are there to advise you how to build your devices and how you can take care of the ignition risk by using the right materials and wiring and stuff like that. So they are expert in technical assessment and do hazard gas testing as well. And that will remove the bottleneck, because DNV has said they want to cooperate with all the oil and gas company to actually find an EX standard for robotics. And what happened yesterday and what happened today, Stein? Do you remember? You are honored to say it.
Yeah, so you have been running tests with live explosive atmospheres of gas, and there's robots. And we have been sitting on needles to anticipate the result or hear the boom to hear. It's at the Royal Air Force bases in Britain. This testing is getting...
So Spot had passed the first gas test for propane. It walked around in 1 hour and 10 minutes, and there were no ignition at all. We knew that from the beginning. We did that. But as we went on stage today, they started the ethylene test now. That was a little bit delayed, but they are now doing that right now. So now we are still on needles and see how that works. So the point is that then we will have it approved in Equinor to use Spot in EX2 areas. That's very important to say.
All right.
Pay attention to that clip I show you now. Pay attention and look at it. Spot, this is, we have invested in Spot for 2 years in the wastewater treatment fields, both in Stura and Mongstad, in Norway. And this is going to have surveillance inspection around the field. And we think we have chosen the most stable or robust robot in the world. If you see in this clip here now, he is so stable, so robust that he can adjust himself because they have matured the machine algorithms for the robots. Because we are completely dependent on independent robots in the field. We are going to improve the OPEX, then we need to remove the operators who can do other tasks instead of doing the routine work. So that is it. Then in this very same project, if you take the next slide, this is Walk. This is a robot collecting water sample from automatic sample stations in the field, in the same area. They take water samples all day through, 24/7, but this robot is going to go docking into a docking station and collect the samples itself. Next. Yes, this is my baby. This is... This project, I use a method I explained in the beginning. This is actually an inspection crawler delivered by a drone in the field. It's going to collect a lot more data than we can do today, so we can have more control of the integrity of our equipment. So this is fit for 6-inch pipes, so we can remove people from heights and confined spaces as well. So there is a huge interest around this project here.
Yeah, no climbers, no scaffolding, no downtime.
Nothing like that, and we're now going to the field in a couple of weeks for the first time, just saying. Another baby of mine, Marcus Robot. Marcus Robot is a surface treatment robot. It does sandblasting, water jetting, painting, and stuff like that. And we have now extended it to NDT inspection as well. You saw that on the movie. Scanner who was scanning a tank wall inside. Removed completely operators from these confined spaces. So there are no operators in the field or in the confined space when the robot is operating. And these also were in second place on finalists in the HAC CEOs HAC Awards in Equinor. And he won, actually, the best scalable robots in Sprint Robotics in World Conference last year. So we actually have achieved some attention to this system as well.
Yeah. Confined spaces is where we lose the most lives, except for... yeah, almost. Yeah.
Yeah. So, and now, yeah.
Remote operations allow maintenance tasks to be performed safely at a facility, while the repair equipment operator is in a different location. This enables repairs to be made while the facility is operational, keeping personnel out of harm's way. In this scenario, there was a leak located at 90 meters from a steam pipe on a refinery flare. The insulation was cut and removed, the pipe grinded clean, remote visually inspected, and the damaged area patch weld repaired, with no requirement to interrupt the flare system. This approach saved the customer having to shut down production, improved safety, increased uptime, and significantly reduced costs.
This is the Love in the Air project. We call it the Love in the Air. It's actually 2 robots combined to repair a steam leakage, as the movie showed, in the air while the flare is in process. So the plant didn't have to shut down, and they repaired it while it was in process. It's actually the idea of my colleague, Arne Berland. His name is Arne Berland. He asked me 1.5 years ago, Anette, is it possible to use this robot to repair the steam leakage? And what did I say? I said, they made it all the way to the moon 55 years ago. This is only 97 meters up in the air, so why not?
But it's a big flame.
With a big flame. And they did. So they actually did that project now this spring.
What is the monetary gain for something like this? The savings for not...
Yeah, we didn't have to shut down the plant, so we actually calculated that to $20 million in savings.
Fantastic.
In the process industry, countless substances are refined into useful products for everyday life. However, some of these substances can have a corrosive effect on the tanks and pipes they come into contact with, leading to metal deterioration over time. These damages often occur in areas that are difficult or dangerous for humans to access. Our technology eliminates the need for human involvement in these hazardous operations. Instead of sending people into tanks or placing them in dangerous environments, we deploy robots capable of both grinding and welding to repair corrosion damage. These robots work faster and more precisely than any human could. This not only reduces risks to life and health, but also allows for the repair of expensive equipment that might otherwise be discarded. Our technology enhances safety, minimizes environmental impact, and offers significant economic benefits.
This is a second combination of these 2, welder and Marcus robot. We call it welder, the welding robot. So this is a second, and this is an ongoing project right now in the field. So this is also to remove people. It's a very difficult area to have people inside these confined spaces because there's no way you can put up a scaffolding in here without destroying these sulfur silos. So this is a complete maintenance program, all the way from inspection to a surface treatment and everything in between, like NDT, welding, grinding, and inspection and all that. Yeah. So, me in the field.
Perfect. Thank you so much, Anette. So, I know we're a little bit over time, but as you can see, me and Anette is very passionate about this. Grab hold of us after if you have some questions or something like that, and we want to work with everyone. Thank you all. today is a packed day. There is breakout sessions, a lot of them, and we'll go to the break and have a short break now, but the breakout sessions start at 9:45 p.m. Thank you so much.
Thank you.